Changing fuel filter. Objectives: change the fuel filter, inspect the fuel lines, check fuel lines for the loose connection, deterioration of damage which could cause leakage. Make sure all clamps are secure. Replace any damaged or deteriorated parts. There should be no sign of fuel leakage or moisture at any fuel connection. Fuel filter replacement. Warning: this work must be performed in a well-ventilated area and away from any open flames, such as gas, hot water heaters. Fuel filter is installed in front of fuel tank inside the left side of the vehicle body. Check for free flow. If blocked, replace fuel filter with new one. Ensure that the loose clips are replaced. Also note that the fuel filter is placed in various positions according to the manufacturer. Please refer to the manufacturer's manual. Layout of power flow from engine to wheels. Objectives: identify the units where power flows from engine to wheels takes place. Power developed in the engine to the wheels. In its simplest form, a transmission may consist of a chain and sprockets as used in a bicycle. A modern vehicle transmission must have a mechanism to engage and disengage the engine from the driveline during gear changes. Must have a range of ratios suitable to the characteristics of the engine. Must operate smoothly and quietly. Must have a reverse gear. Must have a neutral, no drive position. Must have a good life expectancy in terms of mileage. Ignition system circuits and components. Objectives: understand the different ignition systems for petrol and diesel engines. Identify the various components of ignition systems. Ability to read and understand the basic circuits and components. To start the petrol-air mixture burning, the sparking plug must generate a good electrical spark. This must occur just before TDC, top dead center, as the piston nears the end of the compression stroke. Sparking plug. The electrical energy supplied to the plug terminal is passed down the center electrode and jumps across the air gap to the earth electrode. Insulation around the center electrode should prevent the electrical energy taking an alternative path to that required. The voltage, electrical pressure required to cause a spark depends on the gap between the electrodes, gas pressure in the cylinder. It only requires 600 volts to jump the plug gap at atmospheric pressure, whereas 8000 volts may be needed to produce a spark under cylinder operating conditions. Production of a high voltage current. The 12 volts supplied by a battery is far below that required by a sparking plug. Hence, a special system must be fitted which generates the required amount of electricity. Systems in use are coil ignition. Majority of cars use this system. Transistorized, a modern system which is often required on 8-cylinder engines. Magneto, used on motorcycles. This system is a self-contained ignition unit that does not require a battery. Coil ignition. The main parts are ignition coil. This transforms the battery voltage from 12 volts to that required to produce a spark at the plug. Contact breaker. A mechanically operated switch breaks a low voltage circuit and causes the coil to produce a high voltage current. The timing of the spark is controlled by the contact breaker. Distributor. Fitted to multi-cylinder engines, this unit distributes the high voltage current to the appropriate sparking plug. The ignition coil is the boosting transformer generating the current of the high voltage, which is about 20,000 to 25,000 volts, used for making an arc at ignition plug. Spark plug cable, high tension cord. This cable is an insulated high voltage wire connecting the second terminal of the ignition coil to the central terminal of distributor cap and the ignition coil plug terminal of the distributor to the ignition plug. One end of the spark plug cable is joined with the ignition plug terminal by the brass tag and the other end is joined with the ignition plug terminal of the distributor cap. Carbon wire. The resistance conductor is the glass fiber made by implanting carbon into the glass fiber to get constant resistance. The external cover is the ethylene propylene rubber EPDM, which has a good heat and cold resistance. Structure of a spark plug. Electrode. The electrode comprises the central electrode and the ground electrode. As the high voltage is induced from the ignition coil is applied to the central electrodes via the central shaft, a spark will be generated at the gap with the ground electrode. Insulator. The insulator hinders the leakage of voltage by surrounding the core or central electrode. It is a ceramic body which provides a good insulation and prevents the flashover of high voltage of current. Shell. The shell is the metal part surrounding the insulator and has threads in the bottom that firmly fits into the cylinder head. Characteristics of a good spark plug are: it should have a good heat resistance, it should have a good mechanical strength, it should have a good corrosion resistance, it should have a good air tightness, it should keep the self-cleaning temperature, it should have a good electric insulation performance, it should have a strong energy, it should have a good ignition performance, it should have good heat conduction. Brief introduction to the ignition and injection system. Objectives. You can differentiate the ignition system and the injection system of petrol and diesel engine. Fuel injection system. The engine demands that the fuel supplied is 1. Timed to inject when the piston is near the end of the compression stroke. 2. Atomized, broken up into fine particles. 3. Forced with sufficient pressure into the hot, dense, turbulent air. If these demands are not met, the engine will knock excessively and the exhaust will be dirty. Since the power output of a cylinder is controlled by the quantity of fuel injected, the system must be calibrated to ensure that each one of the cylinders receives an equal amount of fuel. Unbalanced fuel supply will cause a variation in the cylinder power output and result in rough running of the engine. Fuel injectors are sensitive and therefore require clean and pure fuel to prevent troubles owing to wear and blockages. Brief introduction of injectors. Objectives. Understand the fuel injector concepts, identify the difference between petrol and diesel injectors, identify the various parts of an injector. Fuel injection is a system for mixing fuel with air in an internal combustion engine. It has now become the primary system used in automotive engines, having almost completely replaced carburetors in the late 1980s. Each fuel injection system is designed and calibrated specifically for the type of fuel it can handle, like gasoline or petrol and autogas, LPG also known as propane, ethanol, methanol, methane, natural gas, hydrogen, and diesel. With the advent of electronic fuel injection, the diesel and petrol hardware has been much similar. However, a wide variety of injection systems have existed since the earliest usage of flow internal combustion engine. Primary functional difference between a carburetor and fuel injection is that fuel injection atomizes the fuel by pumping it through a small nozzle under a high pressure, while a carburetor relies on low pressure created by intake air rushing through it to add the fuel to the air stream. The fuel injector is only a nozzle and a valve. The power to inject the fuel comes from farther back in the fuel supply from a pump or a pressure container. The process of determining the amount of fuel and the delivery into the engine are known as fuel metering. Modern systems are all electronic and use electronic engine control unit (ECU) for metering. SPFI and MPFI. Multi-point fuel injection injects fuel into the intake port just upstream of the cylinder intake valve, rather than at a central point within an intake manifold, referred to as SPFI or single-point fuel injection. Injection nozzles, diesel. Injection nozzles for diesel engines feed the fuel into the combustion chamber, vaporize the fuel, shape the injection process and seal the combustion chamber. They consist of the nozzle body or nozzle holder assembly and the nozzle needle. The nozzle holder assembly provides pressure-proof mounting in the cylinder head and contains 1 or 2 pressure spring, as well as other components for adjusting the injection pressure. The injector receives control inputs from the ECD to open and close the nozzle needle. Modern fast-switching solenoid valve injectors in commercial vehicles can produce as many as 5 injections per working cycle.